Consuelo, everybody. Hope you're having a great day today. I know this will make your day even greater. You will have loads of fun with this. Okay, first thing I want to point out, I'm going to show you, I've done all these problems with you before. I'm going to show you what I've done in the past. And then I'm going to show you what's a fairly typical way to do it. It's not that unusual. It's not necessary, though. Sometimes it is, but not in these problems because Alex doesn't give you problems that are particularly difficult. So anyway, just going to show you something. Now, these are equations that are called quadratic in form. All right? I'm not going to go into the reason why, but let me just show you what to do. Okay, so basically we're going to solve these. So again, what do you do to solve? Set it equal to 0, factor, set each factor equal to 0. Okay, so here what we have to do is it's not 0 yet, so we've got k squared minus 10k plus 9 equals 0. And then we factor this into k minus 9 and k minus 1. And then k minus 9 equals 0. And I've said you can skip this step. There is a reason why I'm writing it, though. And then k equals 9 and k equals 1. Fine. Okay, so how about number 2 here? Same thing. Set it equal to 0. Factor. So it's a trinomial, so we look at the first term, last term, check with the middle. So what gives us x to the fourth? X squared times x squared. What gives us 9? Negative 9 and negative 1. And that'll give us a negative 10x squared in the middle. Fine. Does this factor again? Yes, it does. Each of these is the difference of squares. So I'm going to look, what times what gives us x squared? X times x. What gives us 9? Minus 3 and plus 3. And now for the x squared minus 1. What times what gives us x squared? X times x. What gives us negative 1? Negative 1 and plus 1. And then if I set each of those equal to 0, you'd end up getting 3, negative 3, 1, and negative 1. Now, quite frankly, that's the way I do it. But I'm going to show you another way. And I'm going to erase this because I kind of need some space. But on your paper, you should have this written down first, and then maybe draw a line and say or. Okay? You can probably write it in smaller space than I can with this Apple pen, which kind of takes up a lot of space on the paper. Okay, so I'm going to go through the or part of it. All right, what they do is this. And it's not just Alex. And this isn't a bad way to do it. Okay, you know, sometimes I say, whatever you do, don't do this. No, it's dangerous, and I'll eventually tell you why it's dangerous, but myself, I prefer just to factor. Okay, what they do is this. First of all, they set it equal to 0. Okay, now notice, this is the square of that. Okay? X to the fourth is the square of x squared. If I square x squared, I get x to the fourth. Well, what you're going to do, and you don't have to do it this way, by the way. I really don't care for this myself, but that's okay. Either one's fine. Take the 1 and call it some other letter other than the letter that's there. I'll pick K. You know, maybe some bizarre letter that really sticks out, okay? And I'm going to set that equal to the thing that is squared, okay? The x squared. Now, it's kind of confusing here. Remember I said at the beginning, this is the square of that, okay? I'm going to take the one that's not the square of the other one and set it equal to k. So in this case, I'm going to take the x squared and set it equal to k. Okay, now, I'm going to substitute k in for x squared. Well, what would that make this? K squared minus 10k plus 9 equals 0. And if you find that confusing, quite frankly, I don't blame you. That's why I don't really care for this method myself. I just like to factor, but I'll just show it to you. Now factor this. So we have k minus 9, hopefully this looks familiar, times k minus 1. And then what? K equals 9 and k equals 1. Now here's the danger. Look at the original equation. It doesn't have a k in it. I'm not asking you to find k. I'm asking you to find x. Well, okay, what do? I knew from up here that k was x squared. Well, I found k, so now I substitute back in x squared for the k. And now, set it equal to 0. Factor it. And if this seems like a lot of work to you, I agree with you. That's why, I'm just not that excited about this method. But it helps some people, so that's fine. Okay? And then x equals 3 and negative 3 and 1 and negative 1. Which if you go back and look at the way I did it before, I got it, and I got it a lot faster than this. But so I show you that. I'm going to go back now and, again, redo it the way I did it the first time. But I want to show you both ways. But take a look how much work this took. Now, if you just factor it, it really doesn't take that much work. Okay? Again, it's a trinomial. So we look at the first term, last term, check with the middle. So x squared times x squared gives us x to the 4th. Minus 9 and minus 1 gives us 9. And then we can factor this as x minus 3 times x plus 3. And I know I'm going through this quickly, but it's because I've already gone through it before, a couple minutes ago. And so we get x equals 3 and negative 3, 1 and negative 1. Okay? It just seems a lot easier to me. Okay, let me show you another example, and I'll show you several examples here. And I'll show it to you both ways on each one. Okay, this is simply going to be x times x is x squared minus 7 and plus 2 gives us the minus 14 with negative 5x in the middle. So x equals 7 and negative 2. Fairly simple. Okay, now, what would this be? It's the same equation. What times what? It's a trinomial. What times what gives us the first term? 2x plus 37 times 2x plus 37. Sorry, I blew this when I wrote this problem. Bummer. Okay, I'm going to change the problem, okay? So I'm going to make the second one 2x plus 37. Okay? So on your paper, you're going to have to change that. Okay? So it's 2x. The way it was written, we couldn't do this at all. So it's 2x plus 37 times 2x plus 37. Okay, what gives us negative 14? Again, don't worry about the middle term. Negative 7 and plus 2. That gives us negative 14. That gives me a negative 5 times 2x plus 37 in the middle. Again, I apologize for I can't call it a typographical error, but, my writing error there. It should have been 2x plus 37. Okay? All right. Then what does this simplify into? If I simplify this whole thing, you just get 2x plus 30. And if I simplify this whole thing, it should be equal to 0. You get 2x plus 39. And then you should pretty much be able to just look at this and figure out what the answer is. But if not, set each one equal to 0. Unfortunately, the bell just went off for some reason. Anyway, so x equals negative 15 and x equals negative 39 halves. Okay? Now, let me show you the way to do it using the method that I talked about above in number 2. Okay. This thing right here is the square of that. Sorry, I apologize. This thing is the square of that. So we're going to take the one that's not the square and set it equal to k. So we call that 2x plus 37. Okay, now what does that make this? That makes this thing, that thing squared, minus 5 times that thing, minus 14 equals 0. And now let's factor it. If you notice, it's the same problem as number 3. So that's going to be k minus 7 times k plus 2 equals 0. Therefore, k equals 7 and k equals negative 2. Now, the problem is, don't stop there. I'm not asking for k. So what was the value of k? It was 2x plus 37. So we're going to take 2x plus 37 equals 7, and 2x plus 37 equals negative 2. And if we solve these, we'll get x equals negative 15 and x equals negative 39 halves. And I'm going to leave that one the way it is. Now, you might be saying at this point, hey, that's easier. Yeah, there are times when it is easier. Myself, I just kind of prefer to factor it as it is, but, up here in number 2, I think it's probably easier just to factor it. But as the problems become more complicated, you might want to consider using this method. Like I say, it's not a bad method. The thing you got to be careful of is this right here, that you don't leave it 7 and negative 2. Okay, that's the danger. But actually, it's a fine method to use. You just got to be careful, that's all. Okay, let's take a look at this. Again, I'm going to do this the way I've been doing it, and just by factoring it, and then I'll show you the way by substituting in a value. Okay, so let's take a look at this. This is the difference of two squares. So, because here we have something squared minus something squared. Oh, gosh, I really blew it when I wrote this thing. This should be equal to 0. Okay, sorry about that. All right. Can't solve it if it's not equal to 0. Okay, what times what gives you the first term? 2x plus 41 times 2x plus 41. What gives you x minus 13 quantity squared? X minus 13 times x minus 13. And then since it's negative, one of them's negative and one of them's positive. Okay, now let's just simplify that. Okay, so in this parentheses, we've got 2x minus x is x, and 41 minus a negative 13 is plus 54. Just simplifying what's in the parentheses. And on the second set of parentheses, I've got 2x plus x is 3x, and 41 plus a negative 13 is going to give me, what's that, 31 plus 28, I believe. Okay, then we'll just set each of those equal to 0. So x will be negative 54, and x will be negative 28 thirds. Okay, so we'll let that sit there for a second. Okay, so you can copy it, and you can just pause the video. Okay, if you want to. So how could we do this with substitution? Substituting in the letter here. Again, this one's going to be a little harder. So let me get rid of all this. Okay. But either way's fine. You take your pick. Okay. What we're going to do is we're going to pick two variables. Because notice neither one is the square of the other. So I'm going to let k be 2x plus 41. And I'm going to let, m be x minus 13. Okay, so that gives us k squared minus m squared equals 0. So we have k minus m times k plus m equals 0. So k equals m, and k equals, let me add one more step in there. So we have k minus m equals 0, and therefore k equals m, and k plus m equals 0, therefore k equals negative m. And now we'll substitute in the values. So we have 2x plus 41 equals x minus 13, and 2x plus 41 equals negative x minus 13. Okay, and if we solve this, I'm short on space here, so you'd bring the x over, and you'd get negative 54. Okay, and in this case, we'd have 2x plus 41 equals negative x plus 13. So we'd have 3x equals negative 28, and x equals negative 28 thirds. Okay? All right. And again, you can take your pick, whichever one you want. All right. So how about this one? Well, this is two terms. And notice they're both the same. Okay, so this one is the square of the other one. So we'll call, oh, I'm sorry. I should have done this, first of all, by just straight factoring. Okay, so what do you look for when you factor? You look for the greatest common factor. What's the greatest common factor here? 5x plus 38, because there are two terms. The 5x plus 38 is in each one. So I take out the 5x plus 38, and what do I get? In the first term, I'd get 5x plus 38, and then plus, and in the second one, I'd get a 1. So we have 5x plus 38 and then this would be 5x plus 39. And if I set each of those equal to 0, I'd get x equals negative 38 fifths and x equals negative 39 fifths. Okay, that's just straight by factoring. All right, well, what if I do it by substitution? And again, if you need more time, you can pause the video and copy that down. What if I do it by substitution? Okay, this is the square of this. So I'm going to take this value and make it k. Okay, so this becomes k squared plus k equals 0. Factor out the k, and we get k plus 1. And now, k equals 0, k equals negative 1. And now let's substitute the value of k back in. 5x plus 38 equals 0, and 5x plus 38 equals negative 1. Then if we solve that, we get x equals negative 38 fifths, and x equals, sorry, what happened there? I think that was the iPad trying to do something for me that I didn't want it to do. Negative 38 fifths, and then x equals negative 39 fifths. Okay? Now, I just want to point out there are two more examples in Chapter 0 of Notes on Factoring, number 19 and 21, where I factored complicated problems like this. But basically, what does factoring come down to? Greatest common factor, difference of two squares of a trinomial, and perfect cubes. And there are no cubes even here, okay? This first problem was trinomial. Second problem is a trinomial. Third problem is a trinomial. Fourth problem is a trinomial. Fifth problem is the difference of two squares, and the sixth problem is greatest common factor. Okay? So some of those are pretty long problems, but hopefully that helps you. And I mean, I could give you many, many different examples of this. These are just, 6 of many examples that I could give you. All right, hopefully that's helpful. Again, sorry about the typo, I guess you could call it. Again, on number 4, the second thing should have been 5 times 2x plus 37. That's on number 4. And on number 5, it should have been set equal to 0. Have a good day, everybody. Bye-bye.